On both the OSI model and the internet model, the application layer is the top layer or the highest layer. On the internet model, it's layer 5. So what is the application layer? It's the software that enables user to interact with the network and accomplish tasks. The easiest example I can think of an application layer program is something like Safari, something like Firefox, Google Chrome, Microsoft Edge. Browsers of any kind really are application layers or application layer programs, and they run application layer protocols such as HTTP and HTTPS. Thank you.
Now we're going to discuss the application architecture. This architecture is the way the functions of the application layer are spread out across the client and the server. It consists of 4 components. The presentation logic. This really comes down to how it appears. Pretty much how it looks, how it functions. It's going to be the shell that you operate in. It's going to be the window that the application you're running operates from. Then there's the application logic. It's sometimes referred to as the business logic, and it can be simple or complex. Next, we have the data access logic. This is the logic in the application that references how the data is accessed. This may be a SQL query across multiple machines. This might be an HTTP request, but it's the logic used to request and access the data. And then the way the data is stored, whether it be stored on a disk, on a SAN, whether it be stored locally, whether it be stored and distributed across multiple environments, those are the contents of the application architecture. Thank you. Here we're going to discuss the host-based architecture. It was really common in the early days of the computer when mainframes were prevalent at banks and government institutions. PCs had not yet really become a concept. In this environment, the client machines were referred to as dumb terminals, and they were just that. They would allow you to send in keyboard input, and they would receive screen input, but that is literally all they could do. The presentation logic, what was being presented, the application that was being run, the access logic of the storage were all singled out on a mainframe computer, and the server contained everything. The servers could get overworked the larger and larger they got, and this architecture in today's society would be much, much more difficult and much more limited than the distributed environments that we have. But the host-based architecture is really a client-server mainframe-based environment where the terminal is just that. It's simply a terminal, and all the work is done on the server. Thank you.
Now let's discuss the advantages and the disadvantages of the host-based architecture or the terminal mainframe architecture. It was extremely simple. Like I said, it was just a serial connection from a terminal into a mainframe. And remember when we looked at our Chapter 1 slides, RS-232 was a serial type of communication at the physical layer. So very simple. It was a single point of control, meaning all the control happened on one machine, on the mainframe itself. The disadvantages were all the traffic went to a single host, and that host could get overworked, and it could become a bottleneck, and oftentimes you'd have to wait quite a bit for your information. Sometimes job scheduling became a big issue. So the disadvantages are it could become a bottleneck. Also, mainframes were so big and so powerful that they were also expensive, and when they wore out, they were expensive to upgrade, and not just expensive cost of materials and the cost of the computer, the installation costs would also be astronomical. So Those are the advantages and disadvantages of a host-based architecture. Thanks. Coming into the 1980s, host-based architecture started to yield to a client-based architecture. During this time, the presentation logic, the application logic, and the data access logic would all run on the client machines. The server held the data strictly as a repository, so it would be responsible for holding and storing the data, for backing it up, and nothing else. All of the work was done client side, and that was a very common way to have things done. And it started to evolve in the early 1980s through the late 1980s. So that's the client-based architecture. Thank you. Let's discuss the advantages and disadvantages of client-based architecture. So now that the processing is being done on the client machines, hardware and applications become less expensive. The architecture is still very simple, so those would be considered advantages. The disadvantages are that all the data all the time sits on the server. Therefore, any type of communication requires data to travel back and forth, which can create a lot of network traffic as well as a lot of bottlenecks. So those are the advantages and disadvantages. It seems like technology's moving along, and as you can see by looking at what's being done where, we can see that we're starting to have a balance between the responsibilities of the client machine and the server machines. Thank you.
Today, the client-server architecture is most highly used. This can consist of a thick client architecture or a thin client architecture. Thin clients are easier to manage. Thick clients have much more functionality. That is because the programming and the application logic resides on the client itself, where the data access logic and the data storage exist on the server. In a thin client architecture, the presentation logic only exists on the client, and that presentation layer would be really like your browser and your operating system. So that's really the only thing that exists there. The application logic, the data access logic, and the data storage logic exist on the server itself. Working at a previous job, I used their college's ERP system, and I was a power user there. They installed client applications on all of the PCs, and the program ran robust. It seemed much more powerful than the one we use here at Albertus today. However, it was much more difficult to manage. Some of the administrators at that job had plugged in IP addresses rather than domain names. So when they changed the layout and the architecture of the server room, the IP addresses had to change, and the techs had to go around desktop to desktop to change those IP addresses. That was one obvious example of a maintenance headache from a thick client architecture. Like I said, the disadvantage from the thin client is the user does not feel the same level of control when it's a thin client and it's based over a browser, and the application logic on the client machine is greatly reduced or doesn't exist at all. So that is the big difference, and those are the advantages and disadvantages to both. From a cost standpoint, I believe that thin client is the way the future is headed, and that's the way things are going. Thank you. Now let's discuss the advantages and disadvantages of the client-server architecture. The advantages are it's more efficient because distributed processing is possible. It allows hardware software from different vendors to be used together. and that makes things better. PCs and Macintosh computers talk nicely. Less bandwidth is required. Disadvantages may involve the way hardware and software from different vendors work together, and in many cases, something called middleware is required, where that middleware basically provides a bridge between the two different systems. That would be about it. Thank you very much. Thank you.
Okay, so we couldn't have a client-server architecture discussion without going a little further into the concept of middleware. Middleware is software that acts as an intermediary by sitting between the client and server applications. A lot of times, different types of software, especially proprietary software, don't communicate well together. In such cases, a bridge or a connection program is needed to allow communication and allow data to be transferred between the client and the server when there are different types of application on each machine and they don't like each other. So if the client applications don't like the server applications, aren't designed to talk together, a bridge or a middleware tool will be put in between to allow the communication. It provides a standard way of translating between software from differing vendors. And it manages the message both bidirectional, both to and from client applications and to and from server applications. And it insulates network changes from the clients. So in my example that I mentioned before, when I had to go around changing all the IP addresses, a middleware solution might have remedied that for me in a single location. It was not the case in that instance, but it could have been. Thank you. With the client-server architecture, there is a two-tiered architecture and a three-tiered architecture that can be employed. As you can see by the diagram below, we have the client tier and the database tier, or tier 1 and tier 2. So on the client tier, in a two-tiered architecture, frequently it can be more of a thick client situation because more processing is going to be done on the client rather than the database. The three-tiered architecture is very similar, except behind the firewall you don't just have the database tier, you also would have an application tier in there. We'll go on to the next slide. Like we discussed in the previous slide, the three-tiered architecture has a client tier, a business logic tier or application server tier, which contains the logic usually for the ERP system or whatever other type of CRM is being used, and the database tier, which would hold something like your SQL server, it might be MySQL, but the application server would hold the business vendor's application. The database tier would hold the database that carries that application. So notice the difference between a two-tier architecture and a three-tier architecture. Thank you.
Now we'll discuss the tiered client-server architecture advantage and disadvantages. The advantages are load balancing is possible. There's all types of load balance software out there. At ESPN they use what's known as the F5 load balancer, which is one of the most common load balancers out there. And with load balancing, you can set up the server access to be round robin, which says this request goes here, this one goes to the next one sequentially, and so on. Or you can fill up traffic on one server till it reaches its capacity, then jump to the other. So load balancing can be done a lot of different ways, and it is highly scalable. The disadvantages are that each tier that gets added is more load on the network. It's more complex, it's more difficult. Application development has more factors which are involved. So hopefully you understand these concepts, and thank you very much. So Now we're going to discuss peer-to-peer architecture or P2P architecture. It was developed a long time ago because it is so simple and it is very flexible in that every server and every client has the same power on that network. So that's why they're called peer-to-peer networks, because everybody is literally your peer. They kind of went away, but in the early 2000s, the rise of Napster and BitTorrent, there was Kazaa, they all became popular file sharing networks, and they all relied on the peer-to-peer architecture. So what that means is all devices can act as a client and all devices can act as a server. And if you remember, any of you worked with Napster and remembered it, you could actually see people connecting to your machines, and you could see yourself connecting to their machines. They had machine statistics involving speed and such. In a peer-to-peer architecture, the presentation logic, application logic, data access logic, and data storage logic exist on all machines, and they're all treated as clients and servers. Thank you very much. Now let's discuss the advantages and disadvantages to the peer-to-peer architecture. The advantages are it's resilient to failure because there are so many servers and so many access points, and that data can be stored anywhere on the network. And bandwidth and requirements are distributed amongst many different networks and many different systems. The disadvantages are finding data. It can be sent out there anywhere. And as many of you know, Napster and peer-to-peer networking have huge security concerns. The integrity of the data is highly questionable in a peer-to-peer architecture, and establishing security protocols and guidelines within networks is extremely difficult in a peer-to-peer architecture. Thank you very much.
Nowadays, not too many of you have gone through a day without hearing the term cloud computing. Cloud computing is the general term for enabling access to computing services over a network, usually the internet. There's plenty of clouds. There's OneDrive. There's the OneDrive cloud. There's the Amazon cloud. There are all kinds of cloud computing type services out there. And we're going to break it down a little bit and give a much more clear breakdown of the different models of cloud computing. The models define who manages each application's function, and it defines the associated hardware and software. So again, the next slide will make this very clear. We're going to go into a lot of detail on the different types of cloud computing, and maybe you'll be able to apply this to your daily routine. Thanks.
Now let's discuss the various cloud computing models, such as software as a service, where all application components and associated hardware and software are outsourced. Salesforce is an example. Another example you might recognize is your application process here at Albertus. That is run as a software as a service product from one of our vendors. Platform as a service is where the application logic and data are managed internally. Microsoft Azure is an example. And infrastructure as a service takes things to a whole new level where the hardware itself is outsourced, and you have access to do what you need to do on it based on your login credentials and your setup there. This makes system administration somewhat easier and somewhat less restrictive for smaller institutions. Thank you very much. I'm not going to spend too much time discussing each individual cell on this spreadsheet here, but please take a moment and look this over and understand what they're explaining here and what is being done and what is not. So if you have any questions, feel free to contact me, but I'm not going to go into too much detail on this. Thank you. Now let's discuss the criteria in which we would use to select an appropriate architecture for your needs. This is more of a managerial function, but it's important to understand. Choosing the wrong architecture for your environment can be devastating. I was watching Shark Tank the other night, and I heard all the website failures and all the problems involving all their websites and how these businesses failed. Actually, it was Beyond the Tank. That was the name of the episode. But in reference to infrastructure, you need to look at the cost of servers, clients, and circuits. You need to look at reliability. Regarding development costs, you have to look at software. It's cheaper on a host-based architecture. Scalability, that is the ability to increase or decrease in computing capacity as network demand changes. And it's often easier in client-server architectures. So infrastructure, development costs, and scalability are the primary criteria. Thank you.
All right, now we're getting into the good stuff. This is the kind of stuff we're going to see on our Wireshark traces. This is the kind of stuff that we're going to be showing through some Linux prompts during class later on. For this week's assignment, we're not going to do too much with HTTP requests, but I do want to tell you this is where it's going to start getting good. So, HTTP, it's the Hypertext Transfer Protocol. It's not the text, it's not the same thing as HTML. They are different. HTML is the markup language that is used within the Hypertext Transfer Protocol. So HTTP consists of requests and responses that get sent through the internet from one machine to the other. So the client is always going to send a request, and the server should send the response. That's pretty much the way that goes there, and we have already seen the HTTP request and the HTTP response in the slide from Chapter 1. So keep in mind, this is an application layer protocol that's being used at the application layer. Thank you. Now, I'm looking here and I see an example of an HTTP request here, and it looks accurate. However, I'd rather show you a real HTTP request, so I'm going to step out of this for a second here. I'm going to go to my browser, and I'm going to refresh www.albertus.edu. So I just refreshed it there. Now, all I'm going to do is I'm going to click on it. I'm going to say inspect element, and it's going to give me the HTML. So in other words, this is the markup language. So this is the message that we've refreshed on. However, this is not the HTTP request, and it's not the HTTP response. To get that, we can actually see it here by clicking on network. I'm going to hit refresh one more time here just to bring up some more stuff so you can see everything gets loaded here. Alright, I don't know why that opened a new tab. I must have clicked on one of these links. Anyway, I will pick on something here like this arrow image here. And here I can see the response headers and I can see the request headers. So I'm telling the server, for example, that hey, I'm using Mozilla 5 on a Macintosh. The referring address was albertus.edu. It shows me the time that this was modified. It gives me the host. Gives me some keep alive information. It'll accept a compressed message, which it's getting. And it will send some response information as well. I can click on this one here. This is HTML. It has a much larger response header, and it also tells me that the context type is HTML. I can tell the different types of server software. For me, it has
The host is coming from trackuvisit.com. I don't know that I like that, but it is what it is. So that's an example of the headers in an HTTP request and response. As you can see, these statuses are 200 here. 200 always means success when you're dealing with HTTP codes. And you'll see that as one of the responses here as well. It will respond with 200 if it was showing up on the screen here. There it is right there, actually. So that's an example of response requests and response headers. So if you look, you get the same information here that you're seeing in the request. However, to me, it looks better to actually see it in the browser. And here is your response body, which is the HTML. Again, we see that over here when we pick on the different types. So if I were to select just HTML here, then I could get the document here by looking at it from the inspector, I believe. Yes, so there would be your HTML. So that's a really, really quick piece there. There might be a homework assignment, and when I say might, I mean there probably will be a homework assignment based on this. Next, I want to go over some terminology associated with email. There's the mail transfer agent, or the MTA. That's usually the client that's usually the server software that handles the mail. In other words, it could be SendMail, it could be Postfix, but it's the mail server software, so that's the server side. The mail user agent now is the formal name given to the client. So you've heard of Outlook, you've heard of Apple Mail. A lot of my coworkers really like Thunderbird. And there's also web clients, and those are also MUAs, or mail user agents nowadays. And you see more and more webmail all the time. So SMTP is the protocol used to send messages to what? An MTA, or to the server. And originally it was set up to only handle text files. And we're going to get into something a little bit important here. We have the Internet Message Access Protocol, or the IMAP, and the POP protocols. So these are protocols used to retrieve messages. The Post Office Protocol, or POP, is starting to become obsoleted. I see more and more systems using the IMAC protocol nowadays. Another important concept is the American Standard Code for Information Interchange, or ASCII. So if I go back to my browser here, I can go ahead and I can look up a few things here as far as the ASCII codes. And I'll take a look at this ASCII table here. So you'll notice this goes from 0 to 127. And actually there's 255 ASCII characters, but this is the standard ASCII character set. Anything from 128 up through 255 is not going to be okay, because you can't guarantee that, and they're not necessarily text characters. So that could present a problem. For example, when I try and look at a binary file here, let me go ahead and find one. You don't have to worry about knowing any of this kind of stuff here. There's logo.png, however. So what I am going to do is I am going to mail myself logo.png. Actually, I'm not going to do that right now. I'm going to include this with your homework, and it will be part of your homework assignment. And the rest of the lecture will be included with the homework assignment. So moving on, an SMTP message format is an RFC 822, and it's a standard for a text message format. Header lines contain information about the message, such as to, from, and the subject. The body section begins with the word data. I've also seen it begin with the word CData. And it only uses standard ASCII characters. In other words, the characters I showed you on that last image that we brought up. So 0 through 127. However, many binary programs and binary binary images include characters that are way above the 127 range. So they have to be UU encoded and UU decoded. And that's going to be discussed on the next slide here. So anyway, I'm not going to go through this right now. We've discussed that already. But I do want to go over the multi-purpose internet mail extension, or MIME. So what this does is it basically takes your attachments that have non-ASCII characters, in other words, characters greater than 127, and it allows you to encode them and decode them. And I am going to be mailing the class an attachment that will be a MIME type attachment. And we're going to go through this. I will have another video presentation to make this easier for you, but we are going to go ahead and decode and encode some messages, and that is going to be your assignment this week, along with the response headers assignment. So like I said, I'm going to keep this hands-on. We're starting to get into the class a lot more now, so I hope you're all ready. Other application layer protocols include the file transfer protocol for moving files between clients and servers, and Telnet and Secure Shell, and that's for executing commands on a remote system. We're also going to go into the topic of DNS and IRC a little bit, but not right now. So we will leave that part for later. I'd also like to point out that the FTP protocol is terribly insecure, and I will be demonstrating that. I'll be demonstrating that in class for the on-ground students. For the online students, I still have to come up with a way to show you, but I do want you to see that both Telnet and standard FTP are very, very insecure formats. And we're going to be able to pull passwords out of our Wireshark traces that we're going to do later on. So that should be pretty interesting for you. And on the last slide, we have video conferencing. And I will go ahead and hit play.
With the improvements in imaging software and audio compression and video compression, video conferencing will be growing, in a major part of data communications in the future will be evolving around video conferencing. Thank you.